Hey guys, today we're going to be solving this problem, which is given that n is a natural number, prove that natural log of n plus 1 is less than 1 plus 1 over 2 plus 1 over 3 plus ... 1 over n. And we solved a few questions like this on my channel previously, but in case you haven't watched those videos, that's perfectly fine. I'm going to be explaining the whole procedure and the solution on how to prove this inequality in this video as well. So if you kind of know how to do this, or if you just want to give this a try, feel free to pause the video and give this problem a go. Okay, so for those who are a little confused, I will walk through the solution with you. So actually, there is an important theorem you will want to know to actually be able to prove this inequality. And the formula that will help us, or the method that will help us, is this method. And I'm going to walk through it with you guys right now. So when k is less than equal to x is less than equal to k plus 1, where k is a natural number, then the following is true. 1 over k plus 1 is going to be less than equal to 1 over x is less than equal to 1 over k. Here, how they got from here to here, they simply swapped this and did the inverse of everything. So that's how we get the 1 over everything, and the inequality, the equal to sign, still holds true over here. Then this is also equal to this. So the integration k to k plus 1 of 1 over k plus 1 dx is less than the integration k to k plus 1 of 1 over x dx is less than integration k to k plus 1 over k dx. And you see that it's basically all in the same order. However, this inequality sign from here has just vanished completely. That's because this inequality sign does not hold true for all the values of x. So we don't put the equality sign over here. So yeah, using this method, you can prove almost any inequality that you want. And this is the exact same method we are going to be using to solve this inequality. So once again, I've gotten our problem right here, and now let's use this method to try and solve this inequality. To try and prove this inequality, excuse me. So here, the first step is to let k be less than equal to x be less than equal to k plus 1, where k is a natural number. So let's write that. When k is less than equal to x is less than equal to k plus 1, we know that this is true. But for this problem, let's just focus on this part. Actually, let me do it in another color. Let's focus on this part only. And you'll see why soon, because this part is actually the key component for us to get both the left-hand side and the right-hand side, which is why I just want to get this part. So we can just copy that because we already know this method, so we can just copy that. So when this is true, then we know 1 over x is less than equal to 1 over k. And remember, the inequality sign still holds true because we haven't taken the integration yet. Now, let's take the integration. So when we take the integration, we do integration k to k plus 1 of 1 over x dx is less than, remember, we get rid of the inequality sign because it doesn't hold true for all the values of x, is less than integration k to k plus 1 over x dx. And we always take the integration with respect to x, or whatever variable you have over here. Now that we have this, let's start solving it. We know we can solve this side. We can also solve this side, but let's hold on for a moment. So let's just write this side as it is. So integration k to k plus 1 over 1 over x dx is less than, once again, not having that inequality sign. And this is simply, we know that this is 1 over k and we're integrating it with respect to x. But this is basically a constant because this is in terms of k, not x. So if it's not in terms of x, it's just a constant, right? So we're just going to take that out, and we have integration k to k plus 1 of 1 dx. Let's further solve this right-hand side. The left-hand side stays the exact same. So integration k to k plus 1 over dx, 1 over x dx is less than, no, equal to and this is just 1 over k. The integration of 1 is just x, k to k plus 1. Solving this, we simply get integration k to k plus 1, 1 over x d of x. The right-hand side would be 1 over k times k plus 1 minus k, which is just 1 over k times 1, which is just 1 over k. So now we have solved the right-hand side. The right-hand side we have solved. Now onto the left-hand side. We see that we have this 1 over k, and we see that it's somewhat in the form of this here. We have 1 over something, 1 over something, 1 over something, so that's a good sign. We're getting somewhere. However, we also have the left-hand side, which is that natural log of n plus 1. So we need to somehow introduce that in this inequality here. So what we're going to do, and most of the time when you're working with inequalities like these, where it's just like 1 plus 1 over 2 plus 1 over 3 dot 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 plus 1 over n, where you don't know the number of terms, then you take the summation of both sides. So let's do that. So if we take the summation of both sides, let's take it from k equals 1 to n, because there are n terms. There are n terms over here, so that's why we're taking it to n. And then we get integration k to k plus 1 of 1 over x dx is less than summation k equals 1 to n 1 over k dx. Oh, not dx, because we're not integrating it anymore. So then, let's start to solve this. Let's say this is the left-hand side, and this is the right-hand side. The left-hand side, let's see what we have. Let me take this a little bit down so we can all see that. On the left-hand side, let's replace k for 1 and then 2 and then 3 all the way up till n. So we get integration of 1 to 2, 1 over x dx, plus integration 2 to 3, 1 over x dx, plus integration 2 to 4, not 2 to 4, 3 to 4, my fault. 3 to 4, integration 1 over x dx, plus dot dot dot, let's replace k for n, so we get n to n plus 1, 1 over x dx. This is just simply equal to integration 1 over n plus 1 of 1 over x dx. And how did I get that? Well, I just condensed all of this to this, because you see, it's basically the same thing. For example, if you have integration of x, 1 to 7, dx, this is basically equal to integration 1 to 2 of x dx plus integration 2 to 3 x dx all the way to integration 6 to 7 x dx. That's because we're integrating that same function. So we can just take this one and let it be equal to integration 1 to 7 x dx. And that's exactly what we did over up at the top. So I'm just simply going to erase this. And now let's solve this. So we get integration, let me do that. Integration of 1 over x's natural log of x, 1 to n plus 1, equals natural log of n plus 1 minus natural log of 1. Natural log of 1 is simply 0, so we just get natural log of n plus 1. And that's it. We solved the left-hand side. So this is going to be an important part. So I'm just going to do that. And we see that the left-hand side that we solved for is, in fact, this left-hand side in the question. So we're getting somewhere. Now, we solved the left-hand side. Let's solve the right-hand side. In order to solve the right-hand side, we did the exact same thing. Let's replace k for 1, 2, 3, all the way up till n, because there's an n here. So we get integration, not integration, my bad. We just get 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, dot, 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 plus our last term, which is n. we can't really simplify this, right? So we're just going to leave it as it is for now. And you could simplify it, but don't, because you will start to see that the right-hand side is actually this right-hand side right here. So we see that the left-hand side is less than the right-hand side, right? Well, we saw for the left-hand side, which was this. So let's write that. This is the left-hand side. The right-hand side, we also solved that. We got this. Let's also write that. 1 plus 1 over 2 plus 1 over 3 plus dot 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 plus 1 over n. And this is in fact what we had to prove. So if you follow if you follow this step, you can solve almost any inequality. So just keep these steps in mind, and then you're good to go for solving any inequalities. Thanks for watching this video, and I'll see you guys next time.